So it's my privilege to be part of this very important event today when we are discussing about the make in steel and for the defense. What I have tried to show here that what are the advanced steels for the defense, aerospace and various type of applications including in the energy sector. When we are talking about the steel, the many platform, the defense which we are using, having the infusion of different type of origin of the equipments coming from the different region. And so we have the variety of grades available in our platform. So the main challenge here for us that how we can develop those grades which are already we have inherited from the outside as a platform. And also when we are trying to design our own system, probably in the many times we try to copy those things and then we try to develop for our own application also. But what I'm trying to show here some of the unique advancement in the processing, where in the conventional steel grades also, by changing the different type of processing technology and different types of alloying, it is possible to improve the properties to a large extent, and that can give a lot of advantage to the designer. So when we are discussing the defense sector, it comes in our mind that different areas of like aerospace scenario, we have a program like light combat aircraft, then also we have the recent one, the AMCA, then you have the UKV, and also the various program coming from the different aircraft, which is like from the aero engine scenario also. We also have the many equipments coming from our in the Indian space scenario. So there we have the varieties of grades, and this also includes the many other alloys also. And also we have in our GSLV Mark III also we have. So what I am trying to show that there is a various combinations of the properties which you are looking for a platform, which includes the defense, and we are talking about the high-end applications. So this calls for a very unique type of processing, and that is why when we are talking about the manufacturing of the steel for defense and aerospace application, the specialty in the melting, nobody can ignore it, and that requires a variety of combination of the equipments. I have tried to combine here at the one place, and you can see that starting from electric arc furnace, then coming to the vacuum induction melting, then also ESR and the VAR, the various combinations are required to get the desired chemistry and also the desired properties which you are looking for the products which can be used for such a critical applications. And if you see the gambit of the equipments, so for any industry to flourish, to go into the defense sector and for do the required properties, you need the various combination of the equipments, right from the primary melting, secondary melting, then of course the thermomechanical processing and different type of cold deformation process, and which requires the combination of equipments like, as I said, electric arc furnace, then also the many equipments coming from that. After once the melting is over, it is also very important that whatever you have the product, you cannot simply process because these materials are very difficult to do the processing. So it requires little bit of generation of a lot of data, and which we say in terms of the thermomechanical simulations, and that gives a lot of idea that how the product can be manufactured using the certain deformation process, which will make the property like microstructure property relationship, and also it will try to identify that how the defect can be avoided during the deformation. And in that, once we talk about that type of equipment, thermomechanical simulations are very important, and that gives a lot of information about that what should be the processing parameter, temperature, then speed of deformation for a given set of materials. And if you try to analyze those things in the proper way, it can result in this type of information. And these things are very much used by the industry. It gives a lot of information about that, what should be the domain for to getting the right kind of microstructure for the product. And you can see from here that the side one, the right side, the top one, and of course partly the bottom one looks to be very appropriate crystallized structure for a given material. Now coming to that, what is the potential for a steel which we are trying to utilize in our system? And when we see that there are many grades which are requires a very high amount of in defense you need properties better than whatever is reported in the normal system, and which can be made by the proper processing technology. And you can see the one example I have shown here, that proper refinement of the grain structure can give a lot of improvement in the properties of this grade, the PH steel of 13-8. Similarly, very popular grade, that Austenitic Stainless Steel 321, where we have a lot of combinations of applications. If you see from application 1, application 2, both are strategic in nature. Then we have the aerospace, space and naval application. And all these 4 or 5 combinations requires a varieties of requirement, and that gives a lot of requirement of the technology in the processing, right from the melting to the thermomechanical processing of this type of product. And you can see that this by controlling the certain amount of processing technology like grain size improvement and also some additions of the micro alloying elements, it is possible to improve the properties of this steel also, and you can get a fairly good amount of properties. And stainless steel having the high strength and also high temperature strength is very useful for certain applications. Similarly, way that we are all aware about that 347 SS347, very popular grade. Aerospace and defense, it is being utilized very extensively, and this steel also has a tremendous advantage. By changing certain micro alloying elements, it is possible to improve the properties, and these things requires a totally different type of technology in as far as the alloying and the processing technology is concerned. Similarly, we can see that even ferritic stainless steel, where it is a single phase, non-hardenable, and it is possible to improve the property here also just by addition of certain amount of alloying elements. It is possible to make it a slight amount of martensite in this, and this steel can be give a very good properties, and it has been utilized very effectively. So what I mean to say that very small additions and tailoring by the metallurgical inputs, it is possible to improve the properties of the steel. So steel has a tremendous potential to improve its properties, and that requires a fairly good knowledge how to do the alloying and then processing, so that you can get the desired properties as required by the designer. But when it comes to the defense and aerospace, the requirement is very high. Also, we can see the Martensitic Stainless Steel, similar way, it is possible to have some change in the properties. So I have just taken few examples that what is the potential, and those potentials are very, very important. And defense, when we are progressing in the defense sector, these things requires to be understood and can give a good knowledge in our system. As we are talking about the make for our indigenization, it is possible to indigenize based on the base which we can get from the outside. So what I am trying to focus that one way, that what is the way out? One is that do the alloying elements, do the properties. So what is that one method that we can go for using the artificial intelligence? Can we utilize this type of method that so that we can improve the chemical composition? And this work has been done. Fairly the good amount of informations are available. It is possible to today cut short the time for our improvement in the properties by designing the alloys based on the artificial intelligence approach. And this has been done, extensive work has been done on this work, but it requires a lot of support from the industry. And whatever time normally we take for making the alloys today by the processing, it is possible to do by this type of by using the AI tools, and it has given a very good result, and more than it is possible. Yeah, it's getting over. We have only last slides. So this is the type of we can have the advantage as we go for the AI. You can reduce the time cycle cost also, and this can give a very good advantage as far as the steel production is there. Some of the steel which is required for the space applications and also nitrogen steel for energy application, power generation. So these are the different grades which has been shown here for the steel production of this. And so this is what I am trying to say, that it is possible to exploit the steel properties of the steel for defense application by utilizing the proper method of manufacturing and the processing technology. Thank you.